Kia ora guys, welcome back to the Year 10 Physical World series. This is video 6 in Forces in Motion. In today's lesson you're going to be learning about reaction forces, which is Newton's third law of motion. And you're also going to be learning about friction as a reaction force. By the end of this lesson you should be able to describe and give examples of Newton's third law of motion, describe situations where friction is useful and where friction isn't useful, and explain how friction can be increased or reduced. So Newton's third law states that every action has an equal and opposite reaction. Because forces always occur in pairs, and they're made up of an action force and an equal, so equal in size, and opposite reaction force. Opposite meaning going the opposite direction of the action. In this picture here, we've got a person pushing with their hands onto a wall. The action force is that pushing onto the wall. And the reaction force is the wall pushing back onto this person's hands. And you can see that the action is equal and opposite to the reaction force. Let's look at a few more examples. So here there's a person jumping off this boat. The action is this person is jumping off the boat, whereas the reaction is the boat actually moves backwards in response to this action. In this picture here, there's a person on a skateboard and they're pushing themselves forward. The reaction is that this person is pushing themselves on the ground, whereas the reaction, which is equal and opposite of the action, is the ground pushing back on the person in the opposite direction. Let's look at a few more examples. So in this picture there's two boxers, and this boxer here to the right is punching this boxer to the left on the jaw. The action force is that this person's fist makes contact with this person's jaw and it puts a pushing force onto the jaw. The reaction force is that this person's jaw pushes back on the fist in an equal size and opposite direction. And finally, in this picture here, there's a balloon that's letting out some air. The action force is that the air is gushing out of the balloon in this direction, whereas the reaction force to this action is the balloon is gonna go up in the opposite direction of the air. As you can see, the action and the reaction forces are the same size, but they are acting in opposite directions. I'd like us to focus on friction as an example of a reaction force. So we learnt before that friction is a force that opposes objects moving across a surface. It resists motion, either through a solid, a liquid, or a gas. A solid example could be a box sliding down this ramp. The friction force is going opposite of the direction the box is going, and it's slowing down the box as a result. An example of friction opposing movement through air is this box falling from the sky. The motion of this object is going downwards, but friction, as a reaction force, is acting in the opposite direction. So the air in the sky is opposing the motion of the box. This ramp here is opposing the motion of this box. I don't have an example of friction through a liquid, so water resistance, but you can imagine, let's say, a diver diving through the ocean, and the water is resisting the movement of that diver. So there are many examples where friction is useful, but there are also many examples where friction is not useful and could actually be quite dangerous. Let's start with situations where friction is useful. Some examples are when you're walking, you don't want to be slipping around when you're walking on the street. And so we increase friction by having shoes that grip the concrete. If you have worn out shoes, or if you're using those really cheap jandals to walk on a wet pavement, then you're more likely to slip. And I know I've done that many times. Cycling is another situation where friction is useful because you don't want your bike to be slipping around on the street. So you have tires that tend to be wider, and they have a greater tread depth. And the other situation where friction is useful is while you're driving, because you don't want your car slipping off the road when you're turning a corner. And so we increase friction by having good tread depth on tires and having brake pads. So when friction is useful, you want to increase this friction. And this is usually done by increasing the amount of contact two surfaces have on each other. Now, some examples of where friction is unhelpful is when you have friction in bearings. Now, bearings are a component in machines that need to have reduced friction. That's because friction can slow down how things move in a machine, or friction can increase the heat of the temperature of a machine. That's why people put oil around their bearings. So when someone says a well-oiled machine, it means that we oil bearings because we want to decrease that friction. Another situation is drag or air resistance on a car. We don't want air resistance on a car because that means it's going to use more fuel to try and counteract that friction reaction force. So how do we reduce the friction on our cars? Well, we make sure that the design of the car is aerodynamic, so more curved surfaces, to reduce that friction or that air resistance or that drag. The other situation where friction can be unhelpful is when there's drag or friction on a snowboard. Now, why is this unhelpful? When you're on a snowboard, you want to go really fast down a snowy hill. So what companies do is they lacquer the surface of the snowboard to make it smooth. So when friction is unhelpful, the goal is to decrease friction, and we usually do that by decreasing the amount of contact surface between two objects, and we do that by making surfaces smoother, or we oil surfaces. So that's the end of the lesson. By now you should be able to describe and give examples of Newton's third law of motion, describe situations where friction is useful and where it's not useful, and explain how friction can be increased or reduced. Thanks for watching, and I'll see you in the next video.